All right, guys, we're going to talk about how to find the area under the curve y equals x squared from x equals 1 to x equals 3. And we talked about how to do it in a previous video mechanically, but I want to review one particular part. We use this integral sign to find the area. And we realize that this integral sign looks kind of like a stretched out S. But why doesn't it look like a stretched out A? We're finding area, so why an S? Well, the S indicates that we're going to find the sum of some stuff. We're going to be adding up a bunch of things. Now, here's the thing. This is just a weird area. There's nobody knows any kind of formula for finding whatever this shape is, but we can find the area of a rectangle. Because the area of a rectangle is just the length times the width or the base times the height. And we can use this as like one little rectangle, and then we can have another rectangle over here. And we can keep adding these rectangles, and we can make them as very, very narrow. Obviously, to really make this a perfect match, then the rectangles would have to be infinitely narrow. So we can look at just one of these rectangles. And let's say we're looking at the x value x. The height would be x squared, right? Now, what about the width of the rectangle? The width of the rectangle is like a tiny bit of x. So how can we indicate a tiny bit of x width? Well, in calculus, we indicate it by just writing dx. That's all there is to it. So what we're going to be doing conceptually here is we're going to take the sum of an infinite number of infinitely narrow things. Why infinitely narrow? Because in order for these rectangles to actually match, they can't be wide at all. They have to be infinitely narrow. And we're going to need an infinite number of them. So when we look at this sum, we're going to recognize that this integral sign means an infinite number of infinitely small things, or infinitely narrow things. Let's take a look at this. So when we write x squared times dx, this represents the area of just one of the angles. The x squared dx represents the area of just one of the rectangles, x squared being the height, dx being the width. And we also indicate the starting and ending points. Here we go from 1 to 3. So that's where this notation comes from. So conceptually, in the fundamental theorem of calculus, we're going to show how this infinite sum of an infinite number of infinitely small things, we're going to show that this thing, which represents adding up this infinite number of infinitely small things, coincidentally just so happens to equal or be able to be predicted by the antiderivative, which is weird, and that's the fundamental theorem of calculus. We're going to get to it right now.